Tonight we'll be looking at surface integrals. Amen. Surface integral. Okay. We are going to solve some examples as it is. Amen. Yeah. Surface integral. Okay. Okay. Tonight we'll be looking at surface integral. Tonight we'll be looking at surface integral. Yeah. So in this video, if you can see what I am saying, I'm going to explain a surface integral. Then we'll look at this problem here. Assuming you are asked to write a short note on surface integral, this is what you are going to write. Amen. A surface R vector equals to f of u comma v. Sorry, here should be v. Comma v, right? Is called smooth if f of v u comma v possesses continuous first order partial derivative. You understand? It means if the surface will be smooth if it possesses first order derivative. That it implies that if it is of this form, partial r all over any of the function, either partial f. Yeah. So if it possesses something of this form, that is what surface integral is trying to explain. Yeah. Then let f, vector f be a vector function and s be the given surface. Amen. Surface integral of a vector function f over the surface s is defined as the integral of the component of f along the normal to the surface. Amen. This is a vector function along the normal equals to vector f vector times n vector, where n is the what? Unit normal vector to an element ds, and unit normal is equals to grad f all over magnitude or modulus of grad f, comma, that is our ds, the element ds is equals to dx times dy all over unit normal vector times dot vector k. Is that clear? Therefore, the surface integral of f over s is equals to summation of vector function times unit normal vector equals to double integral, that is over s, times vector function times unit normal vector times dx. Here we have the diagram. This is the diagram of the surface integral. You can now see that we have n here, that is unit normal and vector function. At the end we have seated on ds. Can you see? So if, assuming you are asked to write short note on with the aid of the diagram, surface integral, I think this is what you are supposed to write. Are you following? So before we move further to solve this problem, we have a problem, amen, that we're going to consider. Are you following? Okay. So we are going to consider this problem. Okay. Yeah. So far, so good. So let us move further to consider this problem. Let's move further to consider this problem. So, in the question here, they said a particle moves along the curve. This is a physics question, but do you know that physics is mathematics? At the same time, mathematics is physics. True or false? Yeah. So, a particle moves along the curve. This is a surface arrow equals to t raised to the power 3 minus 40i plus t squared plus 40j plus 8t squared minus 3t raised to the power 3k, where t is the time. Find the magnitude of the tangential component of its acceleration at t equals to what? 2. As simple as ABC. Whenever you come across, mind you, this is a vector, true or false. So whenever you come across these questions of this form, what you first consider is differentiation. Yeah, this is vector because it's talking about acceleration. I'm going to explain it for you to understand. Amen. Yes, I will explain it for you to understand. Yeah, it's simple as ABC. So what we need to do here, I hope I can claim all of this, so that we can concentrate on this. Is that clear? Okay, so let me clean everything here. Okay, so if you can see what I am saying is simple as ABC. Here, what we need to do here is, before I move further to solve this in details, here we need to consider unit tangential. Tangential vector. Unit tangential vector. So we name it as t, then this is equals to vector v, that is velocity, all over magnitude or modulus of vector v. Is that clear? Then they said the tangential component of its acceleration, that is our a subscript t, will now be a dot unit tangential vector. Amen. Are you following? So this is what we are supposed to consider. But before we consider this, we need to do some differentiation. Amen. Hope you are following. Yeah. We need to do some differentiation. Please, I want you guys to like this video and share. We need to do some differentiation. Amen. Yeah. So let's do some differentiation. I know some of you, it's been long you leave your O-level calculus. Here, calculus is needed. So let's just consider, let me just refreshing your memory on calculus. So since we have R as the dependent variable, then t as independent variable, t raised to the power of. So let's have it in this form. R is equals to at raised to power n. So if we are to differentiate this function, this is a dependent variable, this is independent, while this is what? Constant, and this is what? Index. So we are differentiating this function with respect to t. So if we are to differentiate this function with respect to t, since it is a vector, so here, okay, let's remove the vector. So here will now be the arrow all over what? The t equals to. We use the index to multiply the constant there, which is what? A. So n times a is either an or na, whichever one, then t raised to the power of n minus 1. So this is the definition of differentiation. This is the mathematical definition of differentiation. Do you understand? Are you following? Are you following? Hope you are following. Are you following? Okay. So if you are following, no problem. So let us fix idea with one example as it is now. Now we have r is equals to t raised to the power 3 minus 40. So if we are to differentiate this function, amen, it means the arrow all over the t will now be equals to, this is our index, two of us, which is the n. Then here is what? Invisible 1, which is a. So 3 times 1 is 3, so 3t raised to the power of n, which is 3 minus 1, two of us. Then what we have here, minus, here we have invisible 1, two of us. So use this one, this is the index, to multiply the constant here, 4. So 1 times 4 is 4, t raised to the power of 1 minus 1, two of us. I'm just teaching you how to differentiate. So the r all over the t will now be equals to 3t raised to the power of 3 minus 1, 2, minus 4t raised to the power of 1 minus 1 is 0. You can now see, right, t raised to the power of 0. So, go back to indices. Anything raised to the power of 0, this is equals to 1, two of us. So 4 times 1 is 4. So therefore, our dr all over the t is equals to 3t squared minus what? 4. This is what we are supposed to have. Any question? I'm just trying to refresh your memory so that you will understand what we are about to do here. Amen? Okay. Do you understand? Any question? Do you have any question? Yes or no? No question, right? It means we can proceed, right? Okay, so let's move further to, as stated, let's move further to consider what we are asked to look for. So now, I will also remind us, they said we should consider the magnitude of the tangential component of its acceleration at t equals to what? 2, right? You know that velocity is the rate of change of displacement with respect to time. True or false? That is the definition. It means velocity is equals to the s all over the t. That is the mathematical definition of velocity. Do you understand? True or false? So it means we are going to apply it here. We will apply it here. We will apply it here. Is that clear? So this s, we can still, s, we can still use s as what? A distance. We can still use r as what? A distance. Is that clear? Yeah. So what we need to do here is simple as ABC. We are going to, we are going to differentiate this function. Amen. So let us differentiate this function. How can we differentiate this function to obtain our acceleration? It's simple as ABC. Okay, what we need to do, acceleration is the rate of change of what? Velocity with respect to time. True or false? So it implies that acceleration is equals to velocity, the v all over the t. So we'll be there, right? So let us move further to consider this. So it implies that we have to first obtain our velocity, before we can obtain our what? Acceleration. How? By differentiating this function twice. So this implies that our arrow, let's write solution, our vector arrow is equals to what? T raised to power 3 minus 4t, all in bracket what? I plus t square plus 4tj, amen. Then plus open bracket 8t square minus 3t square, k, amen. So let's differentiate it. If we differentiate this function, since it is a vector, if we differentiate this function once, that is our velocity. Do you understand? It means our d vector r all over, we are differentiating with respect to t. This is our velocity v. Is that clear? Which is equals to, based on definition of differentiation, what we need to do here will now be what? 3t squared minus 4 times I plus 2t plus 4, right? Times j plus 16t minus, here is 3, sorry, not 2, minus, because look at it here, minus 9t squared times k. Amen. Are you following? Do you understand? Times k, right? Okay. So if you are following, now it means they said at t equals to what? 2, right? So it means anywhere we see t, we have to write 2. So here will be d r all over the t, which is equals to velocity, equals to, we substitute in, because at t equals to 2, here will now be 3 open bracket 2 all square minus 4i plus 2 open bracket 2 plus 4j, amen. Then plus 16 open bracket 2, because anywhere you see t, at t equals to, then minus, let me clean this, minus open bracket 16, minus 9 open bracket 2 all square times k, amen. True or false? Okay, so this we're going to give us, here is 4 times 12, 4 minus, 4 times 3 times 4, sorry, because 2 square is 4, right? So 3 times 4, 12 minus 4, then I plus, here is what? 2 times 2, 4. 4 plus 4I, sorry, J, amen. Then plus 16 times 2, 32, right? 32 minus, here is 4. Because 2 raised to the power 2 is 4. 4 times 9 is 36, right? 36K, true or false? So this implies that 12 minus 4 is what? 8I. Then here is plus 8J. Then here 32 minus 36 is minus 4K, true or false? So it means the velocity at t equals to 2, we obtain this vector, true or false? Then, for us to obtain our acceleration, it means we are going to differentiate this again. So it means differentiating this again, we are going to have d square r all over the t square, which is equals to what? Acceleration. Then, okay, let's put it, since it is a vector, let's put it in a vector form. Yes, acceleration. This is equals to, are you following? Hope you are following. Right? Hope you are following, right? Okay. So, this is a vector form. Please don't forget to share, like, and comment on it. Okay, so I can clean this, right? Let me clean this. So here, if we differentiate this again, we are still using the same differentiation formula. So here will now be, this is a constant, this one will be 0. Why? Because the independent variable is not attached here, t is not here, so it is a constant. So whenever you differentiate a function of this form, here will always be 0. Then here we are going to have 60i, then plus here we are going to have 2j, then here we are going to have plus, if you differentiate 16t, you have 16, then minus, if you differentiate 9t squared, you are supposed to have 18t, amen, k. True or false? It's true, right? Okay, yeah. So far, so good. So let us substitute at t equals to 2. So this implies that d square r vector all over the t square will now be equals to vector a, or if you like, you can convert it to what? Small letter, no problem. Vector a, yeah, equals to t open bracket, t is what? 6t, open the 60, t is 2, then I plus 2j, then plus 16 minus what? 18 open bracket 2t open bracket k. True or false? Are you following? Amen? Okay, you are following, right? Okay, so if you are following, so let's proceed further to consider this. Amen? Yeah, let us proceed further. So our acceleration will now be equals to 6 times 2, 12i plus 2j. Then here we are going to have, here is what, 36, right? True or false? 36, so 16 minus 36, what are you supposed to have? Minus 20k, right? Minus 20k. Am I right? So this is your acceleration. Is that clear? This is the acceleration. Then it said we should consider unit vector, tangent vector. So here, our unit tangent vector, before we can consider the component acceleration of each acceleration, unit tangent vector, tangent vector or tangential vector is equals to, I know I told you, velocity vector all over vector v modulus or magnitude, where you know that magnitude of this is this, true or false. Since it is in what? Three coordinate system, we have x, this is x, y, z, right? So our modulus will now be equals to square root of x squared plus y squared plus z squared. True or false? So here will now be vector modulus will now be equals to square root of what is x here? X squared plus 8 squared, right? Then plus minus 4 squared. Amen? Okay? So here will now be equals to 64, right? 64 plus 64. Here will be plus 16, right? So here is supposed to be, when you add them, you are supposed to have 144, right? So our vector v will now be 144, and square root of 144 is what? Here will now be what? Equals to 12, right? Yeah. Okay, so this will now be equals to, what is our vector? V is 8i plus 8j minus 4k, right? Then all over, what is our modulus or magnitude is all over 12. But if you can see what I am saying, this is simple as ABC. 4, we can factor out 4, look at it. If we factor out 4, here will be 2i plus 2j minus k. True or false? All over what? 12. True or false? True or false? Look at it now. Look at it. Look at the board very well. True or false? It's true, right? That if you can see what I am saying, it's true, right? So it means 4 can divide this. It's 1, 4 to 12, 3. So we can write it in this form, 2i plus 2j minus k all over what? 3. So it means our unit tangent vector is equals to what? 2i plus 2j minus k all over what? 3. Amen? Are you following? So now what we need to do here is for us to consider the tangential component of its acceleration. So it means the tangential component of its acceleration, tangential component of its acceleration, amen, component of its acceleration, amen, will now be equals to, acceleration will now be equals to, that is, let's write it this one, a sub t is equals to what? A dot t unit, sorry, this is unit tangent vector. Thus, mind you, in vector, there is difference between dot and cross. True or false? It is not multiplication, it's dot. Do you understand? Are you following? Acceleration. This is acceleration, right? So let's do it up here. Let's do it up here. So if you agree with me, this implies that our A subscript T is equals to vector dot T, which is equals to our acceleration is what? Is this, true or false? So 12I plus 2J minus 20K dot what? 2I plus 2J minus K, then all over what? 3. True or false? You know, this is dot product, right? So I dot I is always 1. True or false? It's true, right? True or false? It's true, right? Okay. So if you agree with me, here will now be equals to A subscript T, which is vector A dot unit vector is equals to I dot I 1. 12 times 2 is 24, right? Plus J dot J 1. 2 times 2, 4. Then K dot K is 1. True or false? Then minus 20 times 1 minus 1 is plus 20. But mind you, this is all over 3. True or false? So you can now see that we are going to have 48 all over 3. This is how you are going to solve this type of problem. If in case you have any question, please don't hesitate to ask. Drop it in the comment section. I will get back to you. Thank you for watching. Thank you very much. If there is any question, don't hesitate to ask. Please, one thing you should help me do is to share this video, like and comment. I'll be very grateful. Thank you and God bless you. Bye. See you next time.